x minus 7, you are going to take what y is equal to, and you're going to substitute it into the second equation where you see the y. So you get one of the variables by itself. This is still like blurry. Okay. And I want to get this equation in terms of x. So I can take this purple circle and replace this y value right here with a purple circle. So now I'm going to rewrite the second equation with only x's. So I still have this negative 3x. I still have this negative 2. But in place of the y, I'm going to write 5x minus 7. I've replaced that y. Then equals negative 12. That's the hard part. You did the substitution. So the part that you should be used to from Algebra 1 is now how do I simplify this expression to figure out is x 7, is x 1? So I need to distribute, combine like terms, and solve for x. So my first step is the distributive property right here, right? I have a parenthesis with the distributive property. So this negative 3x doesn't change. How many x's would I have? Negative 2 times 5x. I would have negative 10x, right? And then I have a negative 2 times a negative 7. So that would give me a positive 14, a negative times a negative. So are you with me on the distributive property? That should be hopefully pretty familiar. Now what do? Now I'm going to combine like terms. So how many x's do I collect on the left? I'm negative 3 in the whole, and I go 10 steps further in the whole. So where am I? I'm at negative 13x. I'm going to do this all in one step. I'm going to move this 14 to the other side by subtracting it. So now I have negative 13x equals what over here? I'm at negative 12 in the whole, and I'm subtracting 14 more to be negative 26. What's my last step to solve for x in this problem? See how this is going to usually work out like an integer? So x is equal to what? Negative 26 divided by negative 13 is positive 2. You just found half of your answer. You found what x has to be. Now, do you remember what you do next to figure out what y is? Plug it into any of the above equations. There's an easy equation to plug it into. It's going to be the one with the purple circle, because the one with the purple circle already has y by itself. So if you plug in the x in the purple circle, it'll just tell you what y has to be. So do the easy equation. If you plug it in here, there's a little bit more algebra. I'm going to plug in 2. 5 times 2 is 10, and then 10 minus 7. So I'm going to do it right here. Y equals 5 times 2 minus 7. So y equals 3. All right, I found x and y. The solution to a system is a coordinate point. So it's best to write your answer as like a coordinate point 2, 3. This is the intersection point of these two lines, and I just have to graph them. So some of you that struggle with graphing and you make a mistake with the slope or you're sloppy, sometimes algebra is actually easier for you than having to graph the lines by hand and change the equation. Show of hands, this seems vaguely familiar to you. Okay, show of hands, you definitely remember how to do this. It's pretty strong skill from last year. Okay, that's good. It shouldn't be new learning, but I just never know where people are coming in. All right, so let's do one more example here where it's a little bit different. And then we'll do elimination another day, and then you can pick if you like substitution or elimination better, but we're just going to do substitution for today. And then I'll put a problem on the quiz that would be like a bonus with substitution. Okay, we need to get one of these variables by itself. You don't want to start by getting x by itself because you have to divide by negative 4, creating a fraction here and a fraction here. So you want to pick an easy variable, either this y or this y. I would pick the y in the top equation because all I have to do is add 4x to the other side. I don't have a lot of room to show you, but if I kind of write really small that I'm going to add 4x to the other side, y equals 4x plus 6 is the top equation. So now I'm going to circle that y is equal to 4x plus 6, and I'm going to draw an arrow to where it's going in the second equation. Now I have to carefully rewrite the second equation so that I don't make any typos. That's where people make their mistakes, is their copy errors. So I have negative 5x, and I have a minus sign. Then I'm going to put this 4x plus 6 in place of this y, and then I have equals 21. I do need to do the distributive property to distribute this negative sign to both of the terms. So I would really have negative 5x minus 4x minus 6 equals 21. So now I'm going to do the collect my like terms. How many x's do I have over on this left-hand side? I have a total of how many? Negative 9 x's. And then I'm going to kind of do the step here. Add 6 to the other side. So I have negative 9x equals 21 plus 6 is 27. What would be my next step to solve for x? And a positive divided by a negative will give me a negative answer, right? So I'll get a negative 3 as my answer. You guys know the trick with your fingers for nines, right? You don't? 3 times 9? So like you put your 10 fingers up, 3 times 9, you put your third finger down, there's 2 10s over here and there's 7 1s over here, 27. You guys have seen that trick? What's 9 times 6? You put your 6th finger down, you have 5 10s and 4 1s, so 54. So you can do any of the multiples of 9 on your fingers. You put that number finger down. If you wanted to do 4, you put the 4 down. 9 times 4 is 36. So I always think of 27 with 9 with that rule. Okay, so now that I have this negative 3, I'm only half done. I need to take it up here. I like to put it in that circled equation because y is equal to 4x plus 6 and actually plug in the negative 3 up here. So y is equal to 4 times negative 3 plus 6. So 4 times negative 3 is negative 12 plus 6. So it would be negative 6. And then once I have my x and my y, I can write the answer negative 3 comma negative 6. Okay, you're going to try one problem now before lunch. You're going to turn back. Can I change the page? Yeah? People good with that one, or just let me know if you need it, because this is your notes page, so yeah. No, you're adding them. 4 times 3 is 12. It's negative 12. You added the 4 and the 3. Okay, if you just turn the page directly before it, I just want to look at this one solution problem, page right before it, page R1-4. I'd like us in the margin over here to actually show how I would solve for this using substitution. And if you notice, for some reason, this is the easiest problem and students miss it the most because this is the page right before it. Both of them are solved for y. So students get a little bit confused, like, well, which one do I choose? It doesn't matter which one you choose. Let's say that we circle this problem. I'm actually going to rewrite it over here, though. So we've got y equals 1/3 x plus 3, y equals 4/3 x. So rewrite it over in the margin so that I'm not messing with your other notes. But I just circle the first equation and direct it to the y in the second equation. really you're just setting the two examples equal to each other. So you really have 1/3 x plus 3 has to be equal to 4/3 x. What would I do next to get the x's on the same side of the equation, even though they're fractions? What would I do with this 1/3 x? Subtract it to the other side? Does anyone know what 4/3 minus 1/3 is? Yeah, because it's 3/3, right? 4/3 minus 1/3 is 3/3. So 3/3 is equal to 1. So I have, there we go. I figured out that x is equal to 3. And then what's my next step? I'm going to take that 3 and plug it in up here into the original problem, right? So I'm going to say that, okay, I know that x is 3. I'm going to do 1/3 times 3 plus 3 to see if I can figure out my final answer. And my final answer is that y would have to be 4. And didn't I find on my graph over here the point 3, 4 with my lines? So I found that x was 3 and y was 4 using algebra and using the graph. So I should look at this page one more time, not when we come back from lunch, because we're going to do some quiz practice, but what does it look like when there's no solution or many solutions? So we'll do those another time.